Using the quadratic formula, determine the root of the equation x² plus 6x plus m is equals to 0. In question 6a, what does that upside down a and what does that r means, or that e? The upside down a stands for all, and the e stands for member, and r stands for real numbers. So for all m are members of a real number. Okay, so what are real numbers? Real numbers are all numbers in this art. They are all numbers we can count, even including 0. Real numbers are numbers like negative, positive, integer, 0, fraction, decimal, every number, even minus 1 million, any number we can talk about, except complex numbers or imaginary numbers. If you can search for types of numbers, you will see different types of numbers that we have. So both natural numbers, counting numbers, integer of positive and negative integer, they are all real numbers. Okay, so let's proceed. Furthermore, if you can recall, the question said we should make use of a quadratic formula. And you know the quadratic formula we said minus b plus or minus the root of b squared minus 4ac over 2a. So that's what we're going to use to solve this question now. The formula goes as x equals to minus b plus or minus the root of b squared minus 4ac over 2a. That is quadratic formula. So now in that equation they gave us s squared plus 6s plus m equals to 0. Now let a equals to the coefficient of this s squared, and this coefficient of this s squared is 1. So let a equals to 1. For this 6s, we take it as b, so the coefficient of that 6s of that s there is what? Is 6. So b is equals to 6. And for c is m, so c is m. Okay, so having known that, we'll start by solving this. Put this a, b, c, the coefficient, we should put it into this formula now, and let's solve and see what s could be equals to. Give us s equals to minus, remember b is what? 6, plus or minus the root of our b is what? 6 square minus 4 ac is what? Times our a there is what? 1 times our c there is what? M. So times m over 2. A there is what? A there is 1. Okay, so with that, our s is equals to, we have there to be minus 6. Remember, this division is dividing everything out 2, so bring it to this point here, 2 plus or minus the root of 6 squared will give us 36. Okay, 36 minus 4 times 1 is 4. 4 times m is 4m over 2 times 1 is still 2. So okay, now from here we will divide minus 6 divided by 2. 6 here 1, 6 here 2 here, it will be given us what? 3. 2 here 1, 2 here 3. So here we have minus 3 plus or minus, looking at this point now, we can find out that 4 is common in the both sides. So if I factor out 4 out, If I factor out 4, 36 divided by 4 will give me 9 minus 4 divided by 4 give me 1, so I'll be left with m there. Okay, divided by what? By 2. Okay, and the root of 4 is what? Sorry for my board is very small. The root of 4 is what? Is 2, so minus 3 plus or minus, the root of 4 is what? Is 2, so 2 will come out. We are left with into bracket 9 minus m. Okay, divided by what? Divided by 2. Okay, so this 2 here cancel here 1, 2 here cancel here 1, so we'll be left with minus 3 plus or minus the root of 9 minus m. Close the bracket. Okay, so from that, or we can call it, or it could be known as minus 3 plus the root of 9 minus m, close the bracket, or minus 3 minus the root of 9 minus m, close the brackets. Do you know why? Remember that here is minus 3 plus or minus, so one of them will be plus, one of them will be minus. So minus 3 plus the root of 9 minus m into bracket, or minus 3 minus into brackets 9 minus m, to close the bracket. So the question asks us that given that this root differs by 2k, when k is a member of real number and k is not equal to 0, show that k square is equals to 9 minus m. The roots differ by what? By 2k. Okay, so what I'm going to do now, I'll bring out our final answer for s, which is minus, I'll be having minus 3 plus the root of into bracket 9 minus m minus into bracket minus 3 minus the root of 9 minus m. Okay, close the bracket, is equals to 2k. The reason that it differs by 2k, so that means the difference of them will give us 2k. Okay, so now we'll come back to this solving now. Now right here we're going to be having minus 3 plus the root of 9 minus m minus, we times minus and give us plus 3 minus 2 times minus 2 and give us plus the root of into bracket 9 minus m, close the bracket. Okay, which is equals to what? 2k. You should remember. Now we are having minus 3 plus 3, they will cancel each other, so they will cancel each other, and plus root 9 minus m plus root 9 minus m becomes what? Guess. Equals to 2. Yeah, equals to 2 root of 9 minus m, and which is equals to what? 2k. Now we can divide 2 by the both side. 2 cancel 2 here, 2 cancel 2 here, so we are left with the root of 9 minus m equals to k. Remember in school, for us to remove this root here, we will multiply it. This root means half. Remember that? Half. You get that? This root here means 9 minus m, bracket it, raised to power 1 over 2. Okay? Let me write it back down here. Okay, let me just clean this place. Okay. This means this means 9 minus m raised to power 1 over 2 is equals to k. So for me to be able to remove this 1 over 2, which is raised to power 1 over 2, I have to times it by 2. And here too, I also put here 2 raised to power 2. So 2 here will cancel this 2 here. Now I'm left with 9 minus m is equals to k squared. If I commutate this, k squared is equals to 9 minus m. So given that this root differ by 2k, where k is a member of a real number and k is not equals to 0, show that k squared is equals to 9 minus m. This is how you should prove it. Okay, now moving to the next question. For a geometric progression Vn, subscript n, V subscript n, the sum of the first n terms is summation of equals to V1 into bracket 1 minus r raised to power n over 1 minus r. R is not equals to 1, where r is the common ratio. So we are asked to show that s subscript 3n minus s subscript 2n over s subscript n is equals to r raised to power 2n. So we have to show that if Sn